Hello and welcome to this video. My name is Michael Eiler and I'll be discussing the group project for chemical engineering class number 536, or machine learning and dynamic optimization. This was a combined effort by Coulton Karch, Jaron Ellingson, and myself. In this project, we wanted to estimate the physical parameters, or the aerodynamic coefficients, of a small, lightweight indoor fixed-wing aircraft, or known as the Vaporlight. This was a great opportunity for us to not only do work for research that was already being worked on in the lab, but also to leverage the skills that we learned in this class, such as using lots of data and basically extracting parameters out of it, and optimizing the loss in those estimates. Now, what are aerodynamic coefficients? Aerodynamic coefficients are essentially the physical correlation between inputs and outputs. They also help us to understand sort of the stability of the system, both in terms of its ability to respond to a steady state and its ability to, as I said before, take those inputs, whether they're throttle commands or orientations of control surfaces, and correlate that with a future position or orientation of the aircraft. Now, what happens, or why are they important, right? What happens if we have good aerodynamic coefficients? If we have good aerodynamic coefficients, it may look something like the following. So if I tab over to this simulation and run it for you, you can see this airplane is well tuned, and it has well defined and correct, more importantly, aerodynamic coefficients. So you can see it performs that turn very gracefully, and when it comes time for it to drop down, it's able to do so and recover quickly, going back to a steady state condition. Now, if I close this and we change those parameters, let's multiply it by a factor of 10. This is extreme, but hopefully it helps prove that point. You can see it appears functional. It's not falling out of the sky. However, it's also not being very realistic. So this is why it's very important to have not only accurate aerodynamic coefficients, but it also helps you to understand the impact that poor aerodynamic coefficients could have on a controller for this setup. Now, the methods that we used for data capture were a combination of, as seen below, a combination of infrared tracking software known as the Motion Capture Room in the Magic Lab. This allows us to track the exact position and orientation of that aircraft. And it's very precise, and combining that with the recorded inputs given by the pilot, we are able to create a model of what the system should be doing, and then by using several thousand data points, calculate a estimated aerodynamic coefficient for these different coefficients. Now, as you can see in our results below, these were fairly accurate. However, they did split at certain points. One of our running theories behind this is because the wings are not rigid, they're very flexible. As the aircraft flexes, as it shifts its structure, those aerodynamic coefficients will change dramatically. And because we used a fixed value, we told the optimizer to assume that this value would never change over the course of the flight. Now, because this is not accurate, it had to make a choice between preserving the value of the value of the aerodynamic coefficients and making sure that those weren't worse overall, or sacrificing our position estimate in this very small portion. So we believe that this at least could be one of the contributing factors for it dropping, in essence, its accuracy in the middle of the run. Now, what about future results? This is something that we would recommend any future students to work on. Taking these models were not very difficult, but being able to incorporate the flexing of the aircraft in that model and seeing how those or how those aerodynamic coefficients might change through the flight, and seeing if they can actually model that and detect that would be an excellent way to further this accuracy and generate more robust, not only aerodynamic coefficients, but also model the correlation between the flexing of the aircraft and the coefficients themselves. Thank you very much. We really enjoyed working on this project, and we hope that this video was helpful and inspirational to the next class of engineers. Thank you.